This is a qualitative analysis of a rowing stroke in sculling. The analysis is divided into two parts. The first part will look at the blade placement, in particular the catch and release angles, while the second part will focus on maximising the force on the oar through sequencing the legs, body and arms so that the boat is accelerated during the drive. The top image shows the rower taking a good length stroke. This is noticeable from the catch and release angles, where in the bottom image the stroke is shorter. The distance the blade moves in the water influences the boat speed. As the longer the stroke, the further the boat will travel, provided the force stays the same. In the top image, we can see that the rower achieves a good stroke length as the blade enters the water at a large catch angle. The catch angle of a good stroke is 73 degrees compared to 69 of a stroke that is not so good. This difference in catch angles is due to the point in the stroke at which the blade enters the water. In the good stroke, the blade enters the water at the moment the rower finishes the recovery, while in the bad stroke, the blade only enters the water after the rower has started the drive. This can be observed by the amount of splash coming off the blade. When the blade is buried at the correct time, there is an equal amount of forward and back splash, where if the blade is buried after this point, only a slight amount of forward splash is observed. During the drive phase, the blade needs to be held at an even depth as long as possible. We can see in the bad stroke that the blade starts to climb out at an angle of 63 degrees, while the good stroke is held in the water to an angle of 67 degrees. If we now watch the two strokes overlaid, we can see the difference in catch angles of the good stroke shown in red and the bad stroke shown in yellow. This difference can also be shown for the release angles. So it is obvious that the good stroke has a longer length. So if the same amount of power was applied to the oars in each of the strokes, the boat speed of a good stroke would be higher as the boat moved further. This part of the analysis will focus on a drive sequence. To maximize the force on the oar handle, the movement of the body needs to be sequential, from the largest muscle groups to the smallest. So the legs should extend smoothly, followed by extension of the back, and then flexion of the arms. The stroke is not, however, a 1, 2, 3 movement, where first the legs go, then the body, and lastly the arms. The drive phase of a stroke needs to be executed so that the boat is always accelerating. This means the drive must be initiated by the legs at the catch, and the force needs to be maintained by the body and arms to the end of the stroke. We can see in both images that the legs start to extend smoothly as the blade locks into the water, and that the back appears strong so that the force is directed to the oar. However, as the drive continues, we see that the body on the bad stroke begins to extend quite early. Where the body in the good stroke has remained in relatively the same position as at the catch. As the legs are about a third of the way down, we can see that the body in the good stroke starts to move. This maintains the catch force and the boat continues to accelerate. When the blades are square to the boat, we can see that the arm draw and body extension of a bad stroke are a lot greater than that of a good stroke. This will affect the length of the stroke, as the force on the blade will not be able to be maintained through the drive phase. So the legs, body and arms need to work together so that the initial force is maintained through the drive phase. This requires using the large muscles of the legs first, then adding in the body so that the force is continually accelerated, then adding in the arms to maintain it to the end.